Okay, hello everyone. We're back here at chapter 13, which is hose operations and hose streams, but today we're going to specifically talk about water supply. We've been over this chapter before, so this should be a brief review for us. So we want to talk about the methods of supplying water for firefighting operations. We'll start with fire hydrants. We know that our most dependable water sources are the municipal water sources that we have in our cities. And in order for us to get water from the system itself, we rely on fire hydrants. There's a couple different types of fire hydrants that we're going to talk about. These can provide a consistent volume of water under a constant pressure. The alternative water supply is necessary if our fire hydrants fail. So typically we start out with our tank water, and we have to realize that our tank water is limited in volume. In most cases, we're carrying 500 to 750 gallons in a tank on a fire engine. Some fire engines nowadays are equipped with larger tanks up to 1,000 gallons, and that is certainly helpful. But 1,000 gallons when you're flowing a couple hand lines doesn't go very long. So we have to keep all those things in mind, and our hopes are that we're in an area where we have a fire hydrant available to us. Reasons for failures or reduction in our water supply and or our pressure could be damaged valves and damaged or poor connections. In some cases, it could mean that there is a broken water main somewhere in the system near our grid that we're working. Greater demand on the system than the system can provide. Hydrants on a dead-end water main. And what that means is in a grid system where typically you'll have a fire hydrant placed about every 500 feet in the very dead end of a subdivision, as an example, where it is not looped, and that's the very end with no loop back, then that fire hydrant could potentially produce less gallons per minute. And remember, from fire dynamics or fire behavior, we've talked about how we think in terms of gallons per minute. We want to see those green and blue fire hydrant colors so we know that they're going to put, up to 1,000 gallons per minute or more. Closed isolation valves. There are valves placed in the grid system throughout the system, and this does allow the water company to isolate different areas off in order to perform maintenance, to make repairs when feeders or mains break and that kind of thing. If these valves are closed off in certain configurations, then it could cause us not to have the same loop or double feed that we would normally get, and can decrease what that fire hydrant could possibly provide. Restricted mains, again, is another way. In these older water mains and older systems, and Lexington and Frankfurt deal with this quite a bit in some areas, is you get calcifications and debris and sediment inside these water mains, and that can cause restriction. And then frozen pipes or frozen hydrants. If you get a hydrant that doesn't drain down properly in a dry hydrant situation, as we have here in Kentucky, if that does not drain down, then we could have a frozen barrel, and that can do damage to the stem, damage to the valve, damage to the bonnet, so on and so forth. If you think back to what we talked about in history of the fire service, we talked about why fire hydrants are called plugs. So if we just take a visit back to that for a second, we know that the old water mains were made out of hollowed out logs. So they would take a log and they would hollow that out, and then that would be our water pipe, if you will, and they would place these underground and they would travel. The water would travel through these waterways to where it may be needed. Now, the how do we get into that water was simply you had to dig it up and basically cut a notch, creating a hole, and then you could tap into that log at that time and use the water out of it with the fire hose. Fire hose at that time was made out of leather, riveted together, and it was used in that manner. So whenever they did that, then they would drive a wood wedge back into the hole that they created, and then that would in turn plug, if you will, plug the hole, and it was marked so it could be used at a later date. So that's where we get the term plug when we talk about fire hydrants. So back to the fire hydrant construction and materials. They're made of bonnets, which is the top barrels, which is the body of the hydrant, if you will, and the foot pieces. This is made out of cast iron. The internal working parts of a hydrant are typically made out of bronze, and your valve facings could be made out of rubber, leather, or other composite materials. So this is what our hydrant looks like here, and you can see the pumper outlet nozzle, or what we call the steamer connection, is the larger connection. Typically, this larger connection is on the front of the hydrant, and most modern hydrants will have two and a half outlets, known as a hose outlet. Oftentimes, you can put a gated valve on this outlet and also have supplied two supply lines from, even though that's a smaller outlet. What we have to realize, even if this is a smaller outlet here, if that fire hydrant has the gallons per minute to give and fill two sections, say a 5-inch fire hose, then it's going to do it, and we'll be able to use that water, and we'll be able to gain that much more out of that one hydrant. If the hydrant doesn't have the water to give, if it does not flow that amount of gallons per minute, then we will begin to collapse the fire hose or the supply line. So let's talk about dry and wet barrel fire hydrants here, and we'll start with dry barrel. Most commonly we find dry barrel across the United States. You see some dry barrel across the South. A lot of climates that do not reach freezing, you will see a wet barrel hydrant, which we'll talk about in the second part of this when we're talking about the two types. So we'll start with the dry barrel hydrant. This is used in freezing climates. As you can see from the cutaway drawing here on the slide, you can see that there is no water up in through the barrel up to the bonnet. So the valve for this fire hydrant is underground, and it's going to be below the frost level or below the freezing point. So your valve is right here, as they're pointing to as well. The water is only allowed in the hydrant when the stem nut is operated at the top, and that raises that valve seat up, and it opens up the valve, and then it will fill the bonnet full of water. A wet barrel hydrant is just the opposite. The water is in the hydrant at all times, as you can see in the drawing here. There is an automatic check valve in place right here. So, and that prevents the backflow once we connect to this this hydrant. Right here is your valve and your valve seat. So when we connect up to this and we turn our nut on this fire hydrant, then it will pull away the valve seat, and it will allow water to flow at our connection. And your operating stem is right here. And again, this is used in climates without prolonged periods of sub-freezing climates. Hydrants that are out of service, we place out of service tags or devices on the hydrants. Some of these hydrants can have a locking device that goes over the stem nut, if you will, and that could prevent it from being operated. And usually these are also tagged when that happens. Most water companies will notify the affected fire station in that particular response district, let them know, hey, you've got a hydrant on such and such street that is out of service. We're working to get it back in working order and fixed for you. Once the repair is made, it is a good custom that the water company will then let us know that, hey, this is hydrant is operating now and is ready to go. So at our main fire station at Frankfort, we do have a list on the main marker board at the main station, and it has a list of hydrants that are out of service. That then gets communicated to each station that might be affected, what if it's in their district, if you will, and they also put that on their communication board. Reasons hydrants may be out of service continued: damage to the hydrant, water system, piping, or a pump. So somewhere in the system where water is not able to be moved, then that may be a reason to put a hydrant out of service. Repairs or upgrades that are being performed to the water system. This does happen a lot, especially in the summertime when they're working on the water system. Usually each city they'll have some different small projects where they're upgrading mains or they're upgrading fire hydrants that are aged, or they may just simply be doing repairs on them. Obstructions in the hydrant is another one. Oftentimes in your water systems you will get sediment, you can get rocks, you can get things that are drawn in through the intake, and it makes it all the way into the grid system, and this can also cause obstructions in your hydrant. Anytime that they do a repair and they break open or they take apart the water lines or the mains, they can also get debris in them. That's usually why you have a boil water advisory when there's a main break and there's a repair that's been performed, because you can get some unclean material and mud and things like that in and around where they put those pipes back together. So even though they flush them at near hydrants, you're still going to get some of that, and they do have you boil the water to ensure that there's no microorganisms left to live in it. And then the last thing on our list, as we said a minute ago, is a frozen hydrant. And it does happen even with a dry barrel hydrant. If it does not drain properly, or if that valve seat, if a piece of sediment or calcification gets in there in between that valve seat and seal, it may not completely seal off, and it will leak water back up into the bonnet, and it'll be just like a wet barrel hydrant. I do have a video somewhere. I'll post it if I can find it. But it is a video of a busted bonnet. The valve and the seal was fine. They had to come back and fix the plate that went between the stem and the bonnet, and it looked like a fountain when you float it. Connection tools. How do we connect to our hydrant? You can connect straight up to a hydrant on the steamer side and or the hose side. Typically we will use what's called a hydrant valve or a hydrocyst valve, as you see pictured here, which is the big valve right here on the slide. That valve is designed to go straight to the pumper, and you can also boost pressure if you need to coming out of that back through the pumper. That's why it has three. It has an inlet and an outlet on the side, and then just an outlet that goes straight. All right. To operate the stem and the nut, a hydrant wrench. These wrenches are designed for the specific nut on top. It's usually a hex head style nut, a little different than you could. In theory, you could put a pipe wrench on this and operate it, but it's much easier to use the wrench that is designed for it. And the other key to this is not just anybody can turn this on. The water company can turn it on with a wrench. We can turn it on with a wrench, but somebody just walking up and down the road couldn't just turn this on very easily. Sometimes we'll put a gate valve on one of the hose sides there, as you see on the slide. This could be a Y, this could be just a straight valve. And we'll put that on there to so that we can flow extra lines without shutting the fire hydrant completely down. In your kit, you should also have spanner wrenches there that you see on the salvage cover, and also a rubber mallet or some type of softer hammer, whether it be the harder plastic kind, but it won't do damage to the metal. What we don't want to do damage to is this right here, because it makes it a lot harder to thread on your hydrocyst valve. So that just gets your fittings tight and makes your seal really good. Hose clamps, a few different styles of hose clamps that we see on the slide here. The screw down type right here is designed for LDH or large diameter hose. It is a safer option than the press down type, especially when we're dealing with larger hose. Next to it, you see the press down type, which is common for smaller hose or 1 3/4 1.5 lines. You can crimp down a 2.5 or a 3-inch line with this, but you really got to be careful. And with this type of hose clamp, you have to make sure that you stand to the side like this firefighter in the slide is standing to the side, and keep your foot onto the foot pad there, and then keep both hands on this handle. And it does have a lock right here. When that locks down, keep your hands on it, pressing down, and ease up and make sure that it is locked, because if it's not completely locked and it flies up, it can hit you in your face or your head if you are knelt all the way down. And that's another good reason why we wear all of our PPE when we perform any of these type skills. Anytime that you're dealing with pressurized hose lines, we should have your PPE, including your helmet and your chin strap, applied. Next is the hydraulic press that we see there on the bottom part of the slide. And this is just another variation of a screw down, but it uses hydraulics instead of the screw action. And basically this is also designed for large diameter hose. 5-inch hose is pretty tough to shut down, and if you have to clamp it versus shutting it down at a hydrant for a few seconds, these are the two types that you're going to have to use. And the last one on our list is this little guy right here, and that's a wildland hose clamp. And typically the hose that we're clamping for wildland is not as high pressure. It's mop-up hose. A lot of times it's no bigger than a garden hose. So again, never stand over the handle of a hose clamp when you're applying and or releasing it. The handle or the frame can pop open and it can swing violently upward. So you want to be ready. Keep your arms stiff and keep pressure on this until we've guaranteed. Pull back on it a little bit and guarantee that it's locked. All right, fire hydrant connections. As firefighters, we got to know how to operate our hydrants. So our goal is to provide water through hoses for fire suppression. We flow water from discharge openings to flush sediment out. So when we go to hook up to this hydrant, we get the cap off. We want to crack that open real quick, flow some water, get any sediment or trash out. With our hydrants, we want to perform periodic inspections. A lot of times in a lot of bigger cities, the water companies take care of this. They keep really good records of it. They keep really good records of the flows, the static and the dynamic pressures, and they let us know what those are. We also want to ensure proper operation of the valves and the caps. So when those get checked, if anything needs to be lubricated, it's done at that time. We want to make sure that we can get the caps off in a hurry, and that the valves and the valve stems operate properly. And then oftentimes we are called to assist in doing flow tests, especially if you're a smaller fire department where you may only have, less than 20, 30 fire hydrants. You may be doing that yourself and performing the flow test, the static and the residual flows. Considerations for our wet and dry barrel hydrants: open and close the hydrant slowly to prevent damage and injury. So we know that water weighs a little more than 8 pounds per gallon. And if you think about it, when we fill, especially when you're filling 4, 5, and 6-inch supply line, we've got a lot of water flowing there. Thousands of gallons flowing within, a couple 100 feet, 300 feet of hose. So if we turn this fire hydrant on really fast and we send water going to that pumper, we're sending several thousand gallons of water in the direction of this pumper traveling at 8 pounds, 8.33 pounds per gallon. Boom, what happens when it hits the impellers of that pump? It can possibly do damage, physical damage, to the inside working gears and impellers of your pump. All right, so we do open slow, we close down slow. The same thing if we slam our valve underground here shut really hard, we're hammering water back. We could hammer water back into residents and do damage to toilets and plumbing fixtures and things like that. Completely open or completely closed. It is designed to be fully opened in order to flow its designated gallons per minute. And of course, we want to fully close our hydrants just to make sure no more water in the system is circulating. When water circulates, it creates heat, and we don't need any additional. It also moves sediment in the mains and the lines. We want to verify that water drains out when we shut the hydrant down. So when we shut it down, we want it completely all the way off. That nut will move back and forth, a good half turn or a quarter of a turn without anything happening. There's a little bit of play there, not a half a turn, but about a quarter or less of a turn, and that's okay. It does not have to be completely tight, but we do not want water coming up in the barrel. So when you take the hydrocyst valve off and you leave that cap, make sure that it drained down, that you don't see any water down in the bonnet when you look. If it is not draining, then we want to let the water company know, because there's something there that's not allowing that valve to completely shut. So it could be a gravel, a rock, or sediment, something in there that's between the seal and keeping a little bit of water, from letting it flow in and keeping it from shutting all the way down. They'll have to take it apart and fix it. We want those fixed because especially when it comes cold weather, those can freeze and make them just totally inoperable. And there's nothing worse than pulling up on a fire in the wintertime, hooking up to a hydrant right in front of a house and can't use it because it's froze up. If the hydrant is not draining during the winter, again, the hydrant must be pumped until empty before being repaired or replaced. So they gotta get all that thawed out, pump the water out, find out if it's not closed down all the way before they go to take that thing apart. Soft intake hoses. Not all hydrants have large steamer outlets capable of accepting direct connections. So you may see these. A lot of times you'll see these on private property around factories, but you'll also see the hydrants with the big steamers. Operations on hydrants with 2.5-inch outlets require 2.5-inch or 3-inch hose lines. This is called duals, laying duals. Back in the day in my volunteer department, when I first started in 91, we consistently laid duals, even though our hydrant connections did have the main steamer. A lot of times, if we had to lay a long lay, the only thing we had in abundance was 3-inch hose. Probably about 5-6 years into the game, the city then bought more large diameter hose and equipped several pumpers with the big hose. More efficient to connect whatever intake hose coupling is used to the 2.5-inch reducer coupling. Hard connections for dry barrel hydrants requires more people and is more difficult than soft connections. You have to be the correct distance away, basically, as you see in this photograph. If you're not somewhere within this distance right there, it's just not going to happen, and it does take a couple people to make this connection. Hard intake hose may be connected to the apparatus or the hydrant first, doesn't matter. It just kind of depends on the local protocol. Typically, hard suction line, as we call it, is used for drafting operations, but you can hook it to a hydrant and utilize it in that way. If the hard intake is marked for vacuum use only, then do not use it on the pressurized side or pressurized system. Usually these are marked vacuum use only. I think most of the modern lighter weight hard suction hose is constructed to do both these days. But do pay attention. If it is marked vacuum only, then you cannot and should not hook that up to a fire hydrant. This type of hard intake is only for drafting operations in a static water source, such as a pond, pool, or a portable tank that we set up. Next is mobile water supply operations, often called a tanker shuttle. We call tenders is really the correct term for what we call a tanker, and this is a mobile water supply. This is a vehicle that has a very large tank that is equipped to carry up to 3,000 to 5,000 gallons of water. A lot of departments have smaller ones, 1,500 to 200 or 2,000 gallon tanks, and these are used in rural areas that lack the public water distribution systems and do not have adequate volume and pressure and may not have as many fire hydrants available. So a lot of times this is out in your rural areas. So we create a water shuttle, which we'll talk about, and we may also do relay pumping, which we'll talk about. And that's pumping, drafting out of the pit where water is being dumped to another pumper that is being pumped then to the fire scene. Static water sources can be a few different options that we have. One is lakes and ponds. Oftentimes we'll have ponds and lakes available to us, but we have to have some way to get our two sections of hard suction there. So if there's not a roadway or a pathway close enough that a heavy pumper can sit on and deploy its hose, then that could be a problem. You can draft out of rivers, swimming pools. There could be above the ground swimming pools, below, in the ground swimming pools we can use. There may be above ground animal watering tanks that we can use, or other portable water tanks as well. This is the portable water tank you see most often that is carried on the water tenders, or the tankers as we call them. Again, some static water sources are equipped with dry hydrant connections that allow the pumping apparatus to draw or draft water from the lowest point of the water source. So there are ponds, and farmers will do this. They will put a dry hydrant and it is piped down to the bottom of the pond, and that will have a strainer on it as well, and that allows you to draw from the bottom, and you do not have to get real close to the pond in those cases, and you can draft it right up out of the hydrant. Intake strainers. It is definitely wise to put a strainer, because especially if we're drafting out of a static source such as a stream, a pond, or a lake, that we can draw in not only wildlife but muck, mud, and other debris that we don't want running through our pumper and our hose lines. Ultimately, we can clog up a nozzle pretty quick. So this is a strainer that is attached to the drafting end of the hard suction hose when pumping from a static source. Usually a screen type, an open screen type device is the old style. They do make floaters now that'll float a little bit and but still keep the hose and the strainer submerged. These are designed to keep debris from entering the apparatus or the portable pump. Must not rest on the bottom of the static source except when the bottom is clean and it is a hard surface. All right, water shuttle operations. Basically, we have a water source where we have a pumper drafting water, and then we'll fill the mobile apparatus. So they do their fill, and it takes a certain amount of time to fill the tanker depending on how much water that it holds. It will then travel to the dump site. Once it reaches the dump site, the tanker will dump into the end tank there that you have one pumper drafting out of and supplying water to the scene. So you have to add in your time now it takes to dump, and then that vehicle will travel the course all the way back to the fill site and complete the loop again all the way back to the dump site. So the total time that it takes for this operation to happen will help gauge on basically how many gallons per minute you're going to be able to provide in that shuttle. Certainly, the more tanker trucks that you have involved, the more water that you will be able to supply to the scene. So we use portable water tanks to dump into. Primarily this one right here is what you see the most. It has a frame that keeps everything stiff and upright. We want to try to deploy these on the flattest surface as we possibly can to get the most water in them. These tanks will hold anywhere from 1,500 to, they make them that'll hold up 3,000 gallons. Now this one here it rises as you fill it. So when the water pushes out on the edge, the way it's shaped, it will rise up. These are also effective. They do have to be on fairly flat ground as well. The problem with these is, you tend to get nicks and cuts in them a little easier, but they do work well as well. Deploying our water tanks, spread a salvage cover or some type of heavy tarp on the ground before opening a tank. The tank should be as level as possible. We want to position that tank in the location that allows easy access from multiple directions but does not inhibit the access of it. The discharge outlet should be on the downhill side. Set tanks up so more than one apparatus can offload at the same time. And we want to clean and dry tarps, tanks, and siphons before storing them. You can use multiple portable tanks in tandem. One tank is used for the attack pumper, then the other tank can be used to dump in, and basically you jet siphon from tank to tank. And the mobile water supply apparatus again dumps into the other tanks. When we jet siphon, they make a specific device that you can hook a hose line up to, and basically when you start moving water, it siphons it. You can also put a piece of hard suction from tank to tank, let each end dip down in the water, and you can take a hose line from your pumper and just crack that nozzle and barely flow a little bit of water through there, and it causes that siphon effect, just like the same siphon effect if we were siphoning out our gas tank, if you will. It's kind of how it works. Then they dump into the tank on the very end. Unloading can be done by gravity dumping. A lot of these trucks are equipped with very large dump discharges, dump chutes, if you will, so they can dump right into the tank. There may be jet assisted dumps where the pump, it has a small pump on it and puts it in motion, and then the apparatus mounted pumps as well. Any combination of these methods will work. Filling up our mobile water supply apparatus. To fill quickly, use the best side or the best hydrant available that you can closest to the site. We want to use large hose lines. You can also use multiple hose lines to speed this up. Pumper for adequate flow if necessary, and the multiple portable pumps if necessary. All right, that pretty much wraps up our water supply section. So do review this, take notes on it, and prepare to take your quiz and your exams.